video over chapter 4, questions 10, 13, and 14, which should put us at 10 questions. So last 4 videos, I believe, add up to 10 questions, and that's all we really need for the test. I'm going to do a couple more, probably tomorrow, Sunday, and Monday, but whatever. Starting with number 10a, what volume of 0.25 m solution can be prepared from 16 grams of potassium carbonate? So we've got, oh no, we got this formula, 0.25 m equal to, let's just do another one over here, m equals moles per liter. So 0.25 m equals, we've got grams, we've got the concentration, but we don't have the moles, we don't have the liters. But don't worry, we can use those grams of potassium carbonate to get the moles. So 16.0 grams of K2CO3, that's what potassium carbonate is, over 1 times the molar mass, times the molar mass and mole ratio. So for 1 mole, okay, of K2CO3, if y'all remember this, oh no, this is supposed to be an O right there, K2CO3, you've got 138.204. See, yeah, there you go, 138 point, let's just say 2, let's keep it simple, 138.2 grams per mole. So we got this grams is going to cancel with this grams, and we're going to end up with the moles of potassium carbonate. Okay, so 16 divided by 138.2. 16 divided by 138.2, 0.1157742224. It's kind of too big, so we're going to simplify it. Your calculator is going to say some big number. Let's just say 0.116. Keep it simple. Okay, 0.116 moles of K2CO3. Oh, dang it. There we go. Okay, this is K2CO3. So now we've got the mole, 0.116 mole K2CO3. There we go. Now they are asking us for volume, which is going to be our liters, and we can rewrite this little equation so that we can find the liters. So L is going to equal to 0.116 mole of potassium carbonate over 0.25. So if we plug that into a calculator, 0.116 divided by 0.25 is going to give us something like 0.463. So it's 0.463 liters. Alright, remember, this formula right here is going to be measuring volume in liters. So 0.463 liters. If you want, you can convert this into milliliters by multiplying times 1,000. And it's going to give you 463 milliliters. I mean, if you want, it's just optional. I would just leave it as is, 0.463, but don't forget to put liters. You know, tell the professor what you've got. Okay, number 10b, if the concentration of sodium in an aqueous solution of sodium phosphate, okay, let me just put down real quick, sodium phosphate is going to be Na3. Na3. Sodium phosphate. Okay, yeah. PO4. Okay. Sodium phosphate is 3.2 times 10 to the negative 1 mole per liter. How many grams of sodium phosphate must have been dissolved in 500 milliliters to make the solution? Okay, so we're looking for grams. Our problem right here is pretty similar to the first problem. Oh, this is supposed to be B. I do not have two A's. I got one A, one B. So we got the concentration, 3.2 times 10 to the negative 1. I'm going to rewrite it real quick so that it looks a little bit more simple. 0.32 M equals, well, I don't know because they don't tell me. I'm going to put moles over 500 milliliters. Now, remember in the last question I told you that this equation or this little formula uses liters. So we got to convert 500 milliliters to liters. It's pretty simple. It's just 0.5 liters. Now, we got to find the moles so that we can find the grams, because we can go from moles to grams, grams to moles, whatever. 0.32 times 0.5, okay, just a little multiplication right there, is going to equal our number of moles. So let's work that out. 0.32 times 0.5 should give you 0.16 moles of sodium. Right there, yeah. Sodium. Okay. Now, next, we got to do a little molar ratio so that we can go from just sodium to sodium phosphate. So if we see here, over 1, we can build a little ratio, and we want to end up with sodium phosphate on top so that we can keep that mole of Na3PO4. And then to complete the ratio, we need the number of moles for every sodium phosphate. So if we see here, there's Na3. So there's 3 moles of sodium for each mole of sodium phosphate. If we notice, mole of Na will cancel out. So now we can do 0.16 divided by 3, and we get 0.053. There we go. 3 till infinity. Now, we've got moles of Na3PO4. Perfect. But now we need grams. So, moles of sodium phosphate times, well, I want grams of sodium phosphate. And then I want to cancel the mole of sodium phosphate. Okay, so there we go. We'll end up canceling these out, but I got to figure out the molar mass of Na3PO4. Quick little, okay, there we go. It's 163.936, but I'm gonna keep it simple. I'm gonna just do 163.94. Beautiful. So 0.053 times 163.94 equals to 8.74 grams of sodium phosphate. Beautiful. There we go. 8.74 grams of sodium phosphate. Next, number 13. We're skipping around. 11's kind of hard, man. Not doing all that. 13. How many milliliters of 0.1 m AgNO3 are required to react completely with 750 milliliters of 0.025 m Na2 CrO4. So since we've got two different chemicals, AgNO3 and Na2CrO4, we know we're going to need a ratio. Now, to make a ratio, we got to know the balanced chemical reaction. I'm going to just 2AgNO3. There we go, NO3 plus Na2CrO4 reacts, and we get Ag2CrO4, Ag2CrO4 plus 2NaNO3. Nice. But we're really going to just look at this stuff real quick. Just those two. So for every 2 moles of sodium nitrate, we have 1 mole of sodium chromate. I believe that's what that is. But let's just do a little ratio real quick. For every 2 mole of AgNO3, oh god. There we go, I saved it. We got 1 mole of Na2CrO4. There we go. Okay, just I'm gonna use that later. But now, what can we do for now? We got the concentration of sodium chromate, which is 0.025, and the volume in milliliters, 750 milliliters. So we can actually find out the moles of sodium chromate. So we're still using this frickin' formula, M equals N over L. So if we do M times L, we get the moles, which is N for some reason. That's an N. 750 times 0.025, but in liters. So 750 milliliters, you got to convert that to liters. Just divide it by 1,000, which is 0.75. Yeah, 0.75. So we're going to do this. 0.75 times 0.025. 0.025. And we're going to get the moles of Na2CrO4. Okay. That gives us, stick that in the calculator, 0.01875 mole of Na2CrO4. Beautiful. Okay, now we need to go to the moles of AgNO3, which is where this little guy comes in, right here. You can put this 2 mole of AgNO3 over 1 mole of N2CrO4 times the 0.01875 mole of Na2CrO4 over 1. So mole of Na2CrO4 cancel out, and we end up with the moles of sodium nitrate. There we go. So 0.01875, right? 0.01875, yes, okay. Times 2 gives us 0.0375. Oh my god. 0.0375 mole of sodium nitrate. Yeah. Okay. So they want the volume. So again, we got the concentration. From this formula we can use right here. Got the volume. we got the concentration 0.1 m equals the moles 0.0375 over the liters. Okay, rewrite this so that we can find the liters. It's going to be L equals 0.0375 over 0.1. This is going to give us 0.375 divided by 0.1, 0.375. 0.375. Oh, my bad. My bad, y'all. 0.375. Liters, of course. Liters. I would just leave it like this. Oh, never mind. We have to put it in milliliters because that's what the question says. How many milliliters? Remember, we just multiply times 1,000, and we get 375 milliliters. That's it. All right. Final round, number 14. What is the molarity of a sodium phosphate solution if addition of AgNO3 to 75 milli, is that right? 75 milli, did I copy that? Oh my god. 14. Yes, 75 milliliters of this solution produces 0.205 grams of silver phosphate Ag3PO4. Okay. Right off the bat, we got 0.205 grams. But our formula, we use moles. We know we use moles out here. So we're going to get rid of those grams. 0.205 grams of Ag3PO4. We're going to cancel this out real quick using our molar ratio. So 1 mole of Ag3PO4. Now, cancel this out using molar mass. Molar mass of Ag3PO4 is going to be 418.58. Something like that. Maybe a little more, maybe a little less. But grams cancel out. We end up with moles. 0.205 divided by 418.58. Oh my god, we got 0.000489751 mole of Ag3PO4. Okay. Now we have to go from the moles of silver phosphate to the moles of sodium phosphate. Oh, okay. Remember what I said. If we're going from one chemical to another, so in this case from sodium phosphate to silver nitrate, well, we're gonna need a balanced chemical equation. That's my bad. I should have noticed that right away. So real quick, let's do, we got sodium phosphate, Na3PO4 plus we got AgNO3, because this would be AgNO3 right here. Okay, but then that's not gonna, okay, we need 3 sodium nitrates, 3 AgNO3, so that it's all balanced out. Remember, it's got to be balanced. AgNO3, that's going to react, and we're going to get Ag3PO4, so silver phosphate. Yeah, there you go. So Ag3PO4 Why'd you put that 3? It's because we needed to balance. So 3 Ag, and then here I also have 3 Ag or 3 silvers. Right? Ag is silver, I hope. Okay, and then 3 NaNO, 3 sodium nitrate, 3 NaNO3. NaNO3. There we go. Alright. Balanced. Did I mess this up? Na3. Good, good. PO4, that's right. 3Ag, that's good. NO3, that's also... Wait a minute. Oh, no, wait. Yeah, NO3 times 3. Okay. We're good. Check. Okay. We can build our ratio. So... Oh, man. It's just 1 to 1. Look at this. Ag3PO4. Oh, my God. There's right here. I'm gonna use this one, Ag3PO4. 1 mole. I didn't even have to do that, probably. Well, that was good because then you get to see it. Ag3PO4. It's fine. I don't regret. 1 mole of Ag3PO4 and sodium phosphate. Where's it at? Right here. There's 1 mole of sodium phosphate. So it's just a 1 to 1. Great, great, great. Makes it easy for me. That means I don't have to multiply anything. So this number, guys, I'm not going to copy it in, it's too long, is also the moles of NaNO3. Sorry, sodium phosphate, Na3PO4. Sodium phosphate. Okay. Now they want the molarity. Let's see. Oh my God, what did I do? Okay, okay, there we go. 75 milliliters. Oh, almost forgot. So we're gonna do this big old number, 0.0004. I'm so tired, guys. 89751 moles of Na3PO4, because we're looking for molarity, over, we have 75 milliliters. So we're just going to convert that real quick to liters. That means you gotta, wait, is it? You divide it? Yeah. You divide by 1,000. Oh my God. 75 divided by 1,000. That's how many liters we've got. It's gotta be like 0.0 something. Oh, 75 probably. There we go. 0.075. Yes. 0.075 liters equals the molarity that we're looking for here. So let's do a little. Let's see, can I do 0.000? Okay, here we go. 0.123 751 divided by 0.075 is gonna equal to our molarity. 0.00653,001. I don't want to write this whole thing out. Let's just simplify. 0.0065. There we go. Easy peasy. No need to complicate it. I'm sure this the professor's probably gonna ask us to simplify anyway. So let's just that. We can leave it like this. We can do. I guess we could do scientific notation. 1, 2, 3, 6.5 times 10 to the -3. Let me check. 6.5. I think it's to the -3. But don't quote me. Yes, it is. Okay. 6.5 times 10 to the -3. There we go. Easy peasy.